we're going to talk about exponential growth and decay. So on this notebook page, we have some definitions on top that I want you to go ahead and highlight. So the first thing that we are going to highlight is the definition of A in our exponential function. So A is going to be the initial value or the y-intercept. So depending on if you have a graph, a table, or a situation, it might be presented a little bit differently. The next thing we need to know about is the B value. So the B is going to be the multiplier or that growth factor. And then underneath there, we have different ways that we use to find the B value. So we're just going to write next to here that these are notes on how to find B. Okay, and then right underneath there, we have X is the number of times the initial value will be multiplied by the growth factor. So usually X is going to be an amount of time. So whether it's years, days, weeks, it could be whatever you want. It's going to really tell you what it should be in the word problem itself. So what we're going to do to start is we are going to do these two examples down here. So example one, we have Melissa puts $1,200 into a bank account that earns 2.5% interest compounded annually. How much money will she have in the account after 12 years? So the first thing we need to do is we need to actually write the equation. So in order to do that, we need to find both the A and the B value. So let's go ahead and find our A. So A is going to be your initial value or your y-intercept, which for this situation is 1,200. And then for your B value, you have Okay, so for two examples, our first one we have Melissa puts $1,200 into a bank account that earns 2.5% interest compounded annually. How much money will she have in the account after 12 years? So our first step is going to be to find our A value and our B value. So to start, our initial value A is going to be that $1,200 that she starts with. And then our B value, because we are earning interest, that means that we are going to take that 100% plus that 2.5% that we're earning. So that gives us 102.5%, which converted into our decimal, we're going to move that decimal point 2 over. We get 1.025 for B. So that gives us our equation is y equals 1,200 times 1.025 to the x power. So now to actually answer the question, we need to figure out how much money Melissa is going to have after 12 years. So we're going to take that 12 and we're going to plug it in for x. So we have y equals 1,200 times 1.025 to the 12th power. So you're going to plug that into your calculator and you should end up with $1,613.87. All right, then we have our next example is about the bank of a river and it is eroding. So it currently has an estimated mass of 47 tons of soil. It is losing 2% of its mass every year. How much will be left after 15 years? So again, our first step is going to be to find that A value. So our initial value, or what our riverbank starts at, is 47 tons. Okay, then for our B value, we are going to take, it's losing 2%, so it's going to be different than the first one. So we're going to take that 100% and we're going to subtract our 2%. So it leaves us with 98%, and then again, turn it into that decimal is 0.98 for our multiplier. So put those two pieces of information together and we end up with the equation y equals 47 times 0.98 to the x power. And then our last step is to answer that question. So we have 15 years is what we're trying to figure out. So we have y equals 47 times 0.98 to the 15th power, which leaves us with about 34.71 tons.